The universe just dropped a bombshell, and it's shaking the very foundation of what we believe is possible. Picture this. A planet, 124 light-years away, orbiting a dim red star in a cosmic dance that could rewrite the story of life itself. We're not talking about science fiction, we're talking about the strongest evidence yet, jaw-dropping, heart-pounding evidence that something alive might be thriving beyond our solar system. This isn't just a discovery, it's a cosmic wake-up call, a moment that could change how we see our place in the vast, starry expanse. Buckle up, because this is going to be a wild ride through the most shocking, emotional, and mind-bending revelation of our time. Let's set the stage. There's a planet out there, a world we've been watching with bated breath. It's called a super-Earth, 8.6 times the mass of our own planet, with a radius 2.6 times larger. It's not too close, not too far from its star, a red dwarf that glows faintly compared to our sun. This planet sits in the sweet spot, the so-called habitable zone, where liquid water could pool on its surface, where life as we know it might just have a chance. Imagine a world with oceans, maybe clouds, maybe even something breathing, growing, evolving. This isn't Earth 2.0, but it's close enough to make your heart race. Now here's where things get electrifying. Scientists have been peering at this planet using a technique that's like catching a whisper in a cosmic storm. It's called transit spectroscopy, and it's pure genius. When this planet passes in front of its star, some of the starlight filters through its atmosphere. That light carries secrets, tiny fingerprints of molecules that absorb specific wavelengths. By comparing the light when the planet is in front of the star to when it's not, we can decode what's floating in that alien sky. It's like reading the chemical diary of a world we've never touched. 2 years ago, in 2023, there was a hint, a faint, tantalizing whisper that something extraordinary was happening. A molecule called dimethyl sulfide, or DMS, showed up in the data. Why is this a big deal? Because on Earth, DMS is a calling card of life. It's produced by tiny ocean creatures, phytoplankton, algae, microorganisms that churn it out as they thrive. No known geological process, no volcanic burp or chemical reaction makes DMS in significant amounts. It's a biological signature, a beacon of living systems. Back then, the signal was weak, barely a flicker, but it was enough to set pulses racing. Could this be it? Could we have found a sign of life? Fast forward to now, and the evidence has exploded into something far more compelling. New observations taken with cutting-edge telescopes have zoomed in on this planet's atmosphere in a different wavelength range. The results? A 3 sigma detection of DMS, and possibly its cousin, dimethyl disulfide, or DMDS. 3 sigma means this isn't some random noise or cosmic fluke. It's a signal with only a 0.3% chance of being wrong. That's not just a hint. It's a scream from the cosmos. DMDS, like DMS, is another molecule tied to life on Earth, predicted to be a robust biomarker on planets with hydrogen-rich atmospheres. These are worlds unlike ours, with thick, gassy envelopes that could still harbor life in ways we're only beginning to imagine. Let's pause for a moment to let this sink in. We're standing on the edge of history, staring at data that could mean we're not alone. The atmosphere of this distant world might be teeming with molecules that, on our planet, are made by living things. This isn't just a scientific paper or a blip on a graph. This is a moment that could make you tear up, make you question everything. Are there creatures out there, swimming in alien seas, releasing these molecules as they go about their lives? Are we glimpsing the chemistry of a biosphere, a living, breathing ecosystem light years away? The possibility alone is enough to make your soul ache with wonder. But let's be real. This isn't a done deal. Science doesn't work that way. 3 sigma is thrilling, but it's not the gold standard. For a discovery to be rock solid, we need 5 sigma, a level of certainty where the chance of error is less than 1 in a million. Right now, we're at a crossroads. The signal is strong, persistent, and surviving every test thrown at it. Researchers have run the data through multiple pipelines, tweaked assumptions, and double-checked every detail. No matter how they slice it, the DMS signal holds firm. That's huge. It's a testament to the care, the rigor, the relentless pursuit of truth driving this work. But we're not popping the champagne just yet. Why? Because science demands more. We need more observations, more data, more time to confirm this signal repeats. That's the beauty of discovery. It's not about rushing to a headline. It's about building a case so airtight it can't be doubted. And there's another layer to this. While DMS and DMDS are tied to life on Earth, we have to stay open to the unknown. What if there's a chemical process we haven't discovered, something unique to this planet's geology or atmosphere that mimics these biomarkers? It's unlikely, but it's possible. The universe loves to surprise us, and we're humble enough to admit we don't know everything. This is where the emotion kicks in. Imagine being part of this moment, part of a species that's reaching out to touch the stars and finding something that feels alive. For the first time in human history, we're not just dreaming about life elsewhere. We're seeing clues, real data, that could point to it. This isn't just about molecules or spectra. It's about us. It's about who we are, where we fit, whether we're alone in this vast, beautiful universe. The stakes couldn't be higher, and the feelings couldn't be rawer. Let's dive deeper into this planet. It's a so-called Hycean world, a type of exoplanet that's part ocean, part hydrogen-rich atmosphere. These worlds are strange, exotic, and utterly fascinating. They're not like Earth, with its rocky crust and thin nitrogen-oxygen blanket. Instead, they might have deep oceans beneath a thick, gassy sky, where life could take forms we can barely imagine. Theoretical studies have long predicted that molecules like DMS would be key signs of life on Hycean planets. The fact that we're now detecting these molecules in a real, observed world, that's a plot twist even M. Night Shyamalan couldn't dream up. The star this planet orbits is a red dwarf, smaller and cooler than our Sun. These stars are the most common in the galaxy, and many host planets in their habitable zones. If life exists here, it could mean life is everywhere, scattered across countless worlds around these dim, long-lived stars. The implications are staggering. We're not just talking about one planet. We're talking about a universe that might be bursting with biology, with ecosystems, with creatures we'll never meet, but whose presence we can feel through the light of their stars. Now let's talk about the tech making this possible. The telescopes behind these observations are marvels of human ingenuity. They're not just looking at light. They're dissecting it, pulling apart its colors to reveal the secrets of distant worlds. The data comes from instruments sensitive enough to catch the faintest signals, from photons that have traveled 124 years to reach us. Every measurement is a triumph, a testament to decades of innovation and passion. And the best part? We're just getting started. New telescopes, new missions, new ways of probing the cosmos are on the horizon, ready to take this discovery to the next level. But what does this mean for you, watching this right now? It means you're part of something bigger than yourself, bigger than Earth, bigger than anything we've ever known. This discovery is a bridge between us and the unknown, a reminder that we're explorers, dreamers, seekers of truth. It's a call to look up at the night sky and wonder, to feel the weight of our curiosity and the thrill of what's out there. Whether this signal turns out to be life or something else, it's already changing us. It's showing us what's possible, what we can achieve when we dare to ask the biggest questions. Let's get real for a second. If this is life, it's not going to be little green men waving at us. It's probably microbes, tiny organisms churning out DMS in an alien ocean. But don't let that disappoint you. Life, in any form, is a miracle. On Earth, microbes are the unsung heroes of our planet, the foundation of every ecosystem. If they exist out there, they're proof that the universe isn't sterile, that it's alive, dynamic, pulsing with potential. And if it's not life, if it's a new chemical process we've never seen, that's still a game changer. It means we're learning, growing, uncovering the universe's secrets one molecule at a time. The road ahead is long, and it's going to test our patience. More observations are planned, more data will be collected, and the quest for 5 sigma certainty will continue. But that's what makes this so exhilarating. We're in the middle of a cosmic detective story, piecing together clues from light that left its star when the American Civil War was raging. Every step forward is a victory, every new signal a reason to keep going. And we're not alone in this. Scientists, dreamers, and curious minds across the globe are united in this search, driven by a shared hunger to know. Let's talk about the what-ifs. What if we confirm life on this planet? What does that do to us as a species? It changes everything, our philosophy, our religions, our sense of self. It forces us to confront the idea that we're not the center of the universe, that we're part of something vast and interconnected. It's humbling, but it's also empowering. It means we're capable of finding our cosmic neighbors, of reaching out across the void to say, "We see you." And if it's not life, we still win. We discover new chemistry, new physics, new ways the universe can surprise us. Either way, we're pioneers, charting a path into the unknown. The emotional weight of this moment is hard to overstate. Imagine standing on a beach, staring at the ocean, knowing that somewhere out there, on a world bathed in the light of a distant star, another ocean might be teeming with life. It's a feeling that transcends borders, languages, and cultures. It's a reminder that we're all in this together, all part of the same cosmic story. This discovery, whether it's life or not, is a love letter from the universe, a whisper that says, "Keep looking. There's more to find." So where do we go from here? We keep observing, keep analyzing, keep pushing the boundaries of what's possible. The telescopes of tomorrow are already being built, with sharper eyes and keener senses. They'll probe this planet and others, searching for more biomarkers, more signs of life. And we'll keep theorizing, running experiments in labs to see if DMS could form without biology, to make sure we're not fooling ourselves. The truth is out there, and we're closer than ever to finding it. This is a moment to savor, to hold close, to share with everyone you know. It's a reminder that science isn't just about numbers or graphs. It's about wonder, about chasing the impossible, about feeling alive. We're on the cusp of something monumental, something that could define our century. Whether it's life or a new kind of chemistry, this signal is a beacon, a sign that the universe is full of surprises waiting for us to uncover. So look up tonight. Find a star, any star, and let your mind wander. Somewhere out there, a planet might be alive, its atmosphere humming with the chemistry of existence. We're not there yet, but we're close, so close you can almost feel it.